We're often told that pre-industrial CO2 was a steady 280 parts per million, and humans are the reason for the CO2 increase since 1850. But are those premises actually true? Markus Ott from Germany is going to challenge those claims.
I'm a chemist by trade, and I did my PhD work in the area of the synthesis of phenolic plant components. And since the mid-90s, I'm working in the chemical, pharmaceutical, and life science industry here in Germany. I also have educational background in physics, but I never finished it with any degree or something like that. We should start with some evidence of climate change here in the village in which I live here in Germany. We have a small Löss deposit. Somehow this Löss was deposited on the flanks of a small of hills. They are about 200 feet high. There you can see the Löss. There is a golf course in construction, and it's quite well visible. So that's the remains of the ice age in our village. And there's another thing that might be of interest. There is a small forest. The name of the forest is Vineyard. That means in our dialect, vineyard. This was real vineyard. It is directed, the slope is directed in direction south. It's volcanic eruption rock, which is quite porous and becomes quite warm in the summer. So it's quite well suited for wine. The only problem is, nowadays, the wine would not really grow there because it's too cold. The frost in the spring would damage the bloom of the wine.
About how long was it that they were able to grow vines there?
Probably this was in use during the medieval warm period, probably about 1,000 years ago. But the name is still there. So it's an erosion channel. That's this.
Okay. And by the way, is that you flying by there?
Yes. That's one of my favorite hobbies.
Cool. Very cool.
And this hill is about 300 feet high, and the slope is not very steep, and the slope is terraced. These terraces, I have some pictures of the terrace. There you can see the terraces. They are very strongly eroded, and it's only visible if the sun is quite flat. I talked to farmers. The farmers of the opinion that these slopes were constructed in a time of warm and dry weather, and the purpose was to stop the rainwater from flowing away, so to preserve the humidity for the crops. Last week, I talked to an archaeologist. He was of the opinion that this was done to make the plowing more easy, because the slope will make it difficult to plow properly along the hill, along the slope. Two different opinions, but the slope is relatively shallow. That's right, right?
Yes.
It's not very steep. So to me, the farmer's explanation looks a little bit better. So I would not bet what really was the reason to construct these terraces.
Do you think this area has been continuously farmed for thousands of years? Any idea?
Probably. Not far from my house, Roman, how to translate it, station where for travelers, and most likely something like a station where travelers can change horses and stay overnight, was excavated there. And it was dated approximately to the early Roman times. And this street probably is as old as the oldest streets in the area. It's one of the easiest way to go to the Saar and the Mosel Valley, where which were the major transport ways. The Saar and the Mosel are the big rivers in this area. The book contains no new insights. It's all stuff that's known for quite some time. I just collected it to make it easily available for people who want to know what's going on with this CO2 thing. It's made for an audience. Mostly it's made for an audience with some background in engineering, science, with some mathematics. But the first part of the text should also be accessible for people without any scientific background. For the beginning, I talked a little bit about the IPCC and the political situation, but I think we don't have to talk about it. As I have seen, Christopher Mockton talked about this stuff in your podcast, and I very much agree with him on these issues. For people without a scientific background, I read a little bit in epistemology, so how to know what's true and what is not true. I gave some information about how big is the problem. So how many CO2 is in the air, how much of that is caused by human activity, how many greenhouse gases are there, which part of that is CO2. I decided to attack the main premises of the man-made global warming theory. I refuse to talk about the man-made climate change because that's not a scientific hypothesis that we can test in any reasonable way. The first premise is that the steady increasing concentrations of CO2 in the atmosphere are caused by human activities. The other main premise is that there is an atmospheric greenhouse effect and that the increase of this CO2 concentration causes a dangerous warming of the Earth. So due to the change in the naming from global warming to man-made climate change, the third premise that the temperature is rising is lost. So, and if one of these premises can be proven wrong, then the whole theory is gone. So, and in the text, I will prove that both of these premises are not correct. The IPCC and the media always present us with this graph of increasing CO2 concentration in the atmosphere. The question is, how is it made? It's quite essential for the IPCC that before the Industrial Revolution phase, the CO2 concentration was quite low at about 220 ppm. So from the 50s to today, these measurements are from a station from Hawaii. It's measured by infrared absorption of the CO2 in the air. And the concentrations from there to in the past are derived from ice core samples, which are obtained from several ice core borings in Greenland and in Antarctica. In this context, I would like to mention that there are much cheaper methods to get true measurements from the past, at least about to the 1800s. A German biologist, Beck is his name, studied old lab journals from chemical analysis of air from the 60s down to the early 1800s. He found quite dramatic changes in the concentration of CO2 in the air. It changed from about 300 ppm to 450 ppm. Media want to tell us that these measurements were not very correct and are not reliable. So these are machinery that's used for the analysis. As you can see, that's not something just made for one lab experiment. This is stuff that was used for regular analysis on a daily basis. The margin of error for such methods is in the area of 2 to 5%. So it's quite correct. So now back to the data presented by the IPCC. As mentioned before, this one should be known to everybody. That's the result of the ice core data, which later are continued by atmospheric measurements in Hawaii. So the raw data of these ice core measurements are still available. There they are. There's something strange. You can see in the late 1800s, the aerial concentration of CO2 is very high. It's far away from a pre-industrial 280 ppm. It looks like the late 1800s measurements do not fit to the graph we are showing. The problem was that the numbers in the upper layers of the ice were much too high. So they solved that problem quite easily by cutting out some 18 years and fitting the values together so that they fit to the measurements with the modern equipment. So that's quite a hoax. They had to do that because if these pre-industrial 280 ppm are proven wrong, then the first premise is in danger and the whole theory is more or less proven wrong.
So this air bubble explanation is completely farcical, right? That the bubbles, you can't trust them for the first 80 years, but then they stay the same for 800,000 years?
Yes, there are several difficulties. One is as you can see on this chart, maps with CO2 concentrations in the air measured by satellites. It's quite variable depending on the location. It changes with time, and the deposits mined by these deep ice drillings are preferably in relatively cold areas where the concentration of the CO2 in the air is quite low anyway, even in times when the average concentration of CO2 is relatively high. So the air samples they find in the ice are from areas with an average low CO2 concentration that leads to relatively low results. Back to your question. So the alternative method to the one preferred by the IPCC from the ice bubbles is the examination of plant remains. Plants have stomata, special cells on the underside of the leaf, which they can open for the gas exchange. And the problem for the plant is if they have a lot of these, the name of these cells is stomata. If they have a lot of these openings, they lose a lot of water. So the plant is always tries to have as few of these openings as possible, not to lose too much water. And the number and the density of the density of these openings correlates very well with aerial CO2 concentration of the environment in which the plant grew. So if you have historic plant material, you can determine the density of these openings and correlate that to the CO2 concentration of the environment in which the plant grew. One premise is that you compare the same kind of plants. So you cannot compare, for example, an oak tree with a willow or something like that. You have to stay with the same sort of plants. There is a comparison between the CO2 concentrations reconstructed by the density of these openings in the leaves of plants. And there on this side is a reconstruction of the CO2 concentration for the same period, reconstructed from ice cores. And as you can see, the CO2 concentration reconstructed by this stomata density has much more variation. There's a fluctuation between something close to 200 ppms and something not far from 450 ppms. In the ice core data, you see something like an average. I think that's because the CO2 is enclosed in these bubbles under a very high pressure. It's a gas that's quite well soluble in water, so it will migrate. For example, that's a nice corner. If you take this slice of ice, where you have a very high concentration in the ice bubble, and a few centimeters away, a very low concentration, then the CO2 in the ice bubbles will migrate to the part of the lower concentrations. So in these ice cores, you get something like medium concentration. The time resolution is therefore not so high anymore. So you have two biases. One is in the area with quite cold water, which contains not much CO2 in the air. And the other thing is that diffusion of the CO2 in the ice core. So that's one thing. The other thing is these ice cores are retrieved from quite deep holes with very high pressure differences between the place where the ice is sampled and then taken out, they crack. As far as I know, they also use water as a fluid for the drilling equipment. So there are also other things that can affect the concentration of the CO2 found in the samples. But I think the main effect is that diffusion simply levels it out, and you have changes between 200 ppm and 400 ppm. It's not really a surprise that the average is about quite close to 300 ppm. So that's the thing with the ice cores.
That is the best explanation I've ever seen of this ice core bubble issue.
The premise that the pre-industrial CO2 concentration was always in the area of 280 ppm is at least questionable. Now we will continue and have a look at the effect of human activity on the CO2 levels in the atmosphere. Here I have a page of the IPCC report. It's summary for policymakers. Maybe because these guys normally are not the smartest guys, they were a little bit careless. There is something strange. Now I talk about the results of Murray Selby, Australian professor. I think he was removed from his position at university because of this stuff. He realized that the CO2 concentration rises in a quite regular manner at about between 2003 and 2002. We see a dramatic increase in the human emission. Most likely that was due to the rapid industrialization of China and India. So the emission increased dramatically. So the CO2 concentration in the atmosphere increases more or less in the regular manner, but the emission changed dramatically there. So there, the full thing a little bit in more detail. You see, it's about that the increase is about a factor of 3 approximately. There's obviously a mismatch between the increase of human emission and the increase of atmospheric CO2. So he made an error analysis. I don't want to go into the details how he did that. He posted a YouTube video where he explained the process of the calculation. I hope the link will still work. This emission data, then the result is that the human activity has no influence of the increase in the atmospheric CO2 concentration. That means that there must be a source of CO2 that liberates so much CO2 into the atmosphere that the human activity is close to negligible. It's not seen in the data. So that's quite surprising. And now I will go a little bit in the basic chemistry and thermodynamics of CO2 to explain this result that surprisingly the human activity is not reflected in the atmospheric CO2 concentrations. So some basic stuff that your listeners probably do not need. The issue with the solubility of CO2 in water. There are no really hard numbers available, but even in the Wikipedia, the official number is that the oceans contain approximately 50 times the amount of CO2 that's present in the atmosphere. If you start with a container with water and no CO2, and you add, for example, and in the gas phase, let's say we only have nitrogen. If we add 51 parts or molecules of CO2 in the container, the CO2 will dissolve in the water and approximately 1 will remain in the gas phase. And in equilibrium, the speed at which the CO2 goes into the water and the speed at which the CO2 goes out of the water is the same in the equilibrium. That means it's not always the same CO2 in the air and the same CO2 in the water. They change, but in average over time, the concentration remains the same. But this equilibrium is highly dependent on the temperature of the water. Low temperatures, it's much more soluble than at higher temperatures. And so if you change the temperature of the oceans, the CO2 will change to a higher CO2 concentration in the air. There's how it is described in a simple mathematical way. This equilibrium is, as mentioned before, highly depending on the temperature. So one possible source for the CO2 that causes the increase we observe at the time probably is caused by an increase of ocean temperature. So the equilibrium changes, and since the amounts of CO2 dissolved in the water or in the oceans are so high. So one explanation of the observation that Marie Selby made there is that the oceans outgas as much CO2 from a slight warming that the increase in human emission simply disappears in these vast quantities of CO2 emitted by the oceans. Something that fits also quite well to this. There are also deep sea vents that exhaust pure CO2. There's one application from 2013. They found a deep sea vent that exhausts CO2 close in the Mediterranean, close to the island of Cyprus. Right? So there are CO2 coming out of the deep sea that nobody knows about. So nobody really knows what's going on in the deep sea. And in this case, it's not so deep, so it's accessible with modern diving equipment. And as you can see, the CO2 simply bubbles out of the ground. And these are quite big quantity. It's more or less pure CO2. The origin of that stuff is not clear. It may be that calcium carbonate in some hot areas of the Earth is heated to a degree that it decomposes to calcium oxide and CO2. So nobody really knows where it comes from. But these are quite large quantities that are liberated there. This kind of vents may also contribute to the stuff that increases the CO2 in the atmosphere. And another quite nice explanation is from Piers Corbyn, the brother of the former Labour boss in Britain, Jeremy Corbyn. his hypothesis is that in time periods, some ice melts in the high latitudes and lots of CO2 dissolves in the melting water, disappear in the ocean currents, flow in the deep oceans into warmer areas of the Earth. There they come up again and liberate the CO2 into the atmosphere again. And the currents are quite slow. The traveling time should be in the area of several hundred years. So after a warm period, with some latency, the CO2 is liberated in high quantities. So that would be quite a nice explanation for the findings of Mary Selby, and it fits quite well to the observation. Then there's discussion about the causal effect of CO2 and the rising temperatures in the atmosphere. As there's a graph from Anthony Watts, most likely you know him. As you can see there, the CO2 concentrations in the air correlate measured in the ice cores, correlate quite well with the temperature. In a very famous presentation, Al Gore postulated that the CO2 is the cause for the rise of the temperature. But if you have a look at ice cores with a better time resolution, there is a graphic that I took from Piers Corbyn's website, weatheraction.com. Then you see that there is a lag of time of about a few hundred years. And this time it's about 800 years. Sometimes it's about 600 years. The temperature rises first, and then with a lag of about 800 to 600 years, the CO2 concentration rises. So, but since the cause always predates the effect, that disproves the claim that the CO2 causes the increase of the temperature when the Earth was going out of the ice age. It's quite interesting. Arrhenius, the guy who was one of the first to mention the greenhouse effect of CO2, I think his publication was somewhere in the 1890s. He postulated that the rise and fall of the CO2 concentration changes the temperature, and in this way brings the world in or out of the ice ages. With this high resolution ice core data, this hypothesis should be finished off. So with the methane, it's quite similar. That also is liberated as a result of rising temperatures. But the cause of the rising temperatures is there are lots of theories and hypotheses. I do not really know. The Milankovitch cycles certainly have an influence. But according to Piers Corbyn, if we are using some of his stuff, we should mention him. It's more, the change in the temperature is more a result of changes in the magnetic field of the Earth and of solar activity. Go a little bit deeper in Pierce's idea about the slow transport of the CO2 from the Arctic to the warm oceans. What fits quite well to his hypothesis is the medieval warm period that happened about 800 years before present. He assumes that the CO2 that was dissolved in the melting water in this period now appears in the warmer parts of the oceans and causes the quite strong increase of the CO2, atmospheric CO2 concentrations. The only thing is, in the IPCC report replaced by the famous hockey stick of Michael Mann. To summarize, so now we see the human emissions have no measurable influence on the increase of the CO2 concentration of the Earth's atmosphere. Even if we achieve the net zero goal of our governments, the CO2 concentration in the atmosphere will increase anyway. Doesn't really matter whether we care about it or not. And it's not human activity, but most likely changes in the temperature of the oceans that is responsible for the CO2 concentration in the atmosphere. So these are the important points. We talked about the way the IPCC reconstructs the pre-industrial CO2 concentrations in the atmosphere is a little bit more than questionable. And there, a graph I borrowed by Tony Heller. And as you can see, all these political decisions have no influence on the increase, the lockdowns, and all these agreements didn't change anything.